Good evening. Good evening. Come on, guys. All right. Welcome to NoSQL. I guess intro to NoSQL is what I am trying to provide today. But consider this a generic talk. I'm not necessarily trying to say that you have to use NoSQL or not use NoSQL. I'm trying to introduce some basic concepts. And the important part is that these basic concepts not only apply to NoSQL, they apply for distributed systems. So if you have interest in technologies beyond NoSQL, some of these apply to that too. So this is kind of my loose agenda today. And I have like 30 slides, and I think I even have 30 minutes. So I'll just keep talking. If you feel like interrupting, just don't throw stuff at me. But other than that, we're cool. So I'll be talking about NoSQL concepts, and then some basic concepts followed by the different families of NoSQL, like what kind of databases are available out in the wild. Some decisions, like how do you decide what type of NoSQL database I want to use or not want to use. And finally, I'll be talking about NoSQL database as a service. And that's one of the things I hope to get to today, because I'm a cloud guy, Microsoft Azure, but I'm not trying to sell Azure. What I'm trying to say is go cloud. So some NoSQL concepts we'll touch on today. I'll start with what is the reason NoSQL came into existence, or the whole concept behind NoSQL came into existence. We'll talk about the CAP theorem. Now it sounds boring, but it's pretty interesting. And as I go into my talk, I'll touch on the CAP theorem a bunch of times because it's used widely in anything related to NoSQL. And then I'll touch on the 3 V's, which is volume, velocity, and variety. And basically, when you're selecting just a quick spoiler alert, when you're selecting a NoSQL database, it should meet one of these 3 concepts. So why NoSQL? So this is at the turn of the century, let's say. We were starting to go into the web 2.0 era, and people were starting to build on top of. They were still building on top of databases, mostly MySQL. And this came out of the Web 2.0 era. What was happening was the data was exploding, and they were experiencing some issues with database performance. Mainly what was happening was, let's say you have this record for a particular user, right? You had to go to 3 different tables, in this case, to get to just a single record. That's a single record, right? So that is kind of, you had to assemble and disassemble database. It's called shredding. And this is a phenomenon that you would hear again and again in the NoSQL world. It's called impedance mismatch. So what impedance mismatch is that you have a database, you have an ORM, you have code running on top of the ORM. So you're having to shred the database, reassemble it, shred it, reassemble it. And when you start doing this in volume, let's say billions of records or petabytes of data, it starts to become less efficient. So that was now I will say that relational databases have gotten much better at these, and so have ORM frameworks. But this is the reason NoSQL came into being. So they didn't have a better problem for this. They didn't have a better solution, so they tried to fix it by creating something. And of course, the marketing guys came up with a name. We use SQL, so let's call this NoSQL, and that's how it became NoSQL. NoSQL doesn't mean there's not any SQL. Like, I can show you a bunch of databases that actually have SQL like NoSQL databases that have SQL type queries running on them. What NoSQL means these days is non-relational data. So just think of it that way. Okay, so another problem they had with NoSQL back in the day was in order for a database application to work, the database has got to be able to scale as the traffic started to pick up, the number of reads and writes went up. The database had to scale, right? So this is kind of a x-axis, y-axis, and this represents the users and the load on the server. So as you can see, when the number of users go up, you have to increase the capacity of your server, right? And this is what they had to do back in the day. Nowadays, with cloud computing, things are a little bit better, but if you're running virtual machines, you still have to shut them down and spin a more hefty one up. So this was great, but what was happening was, at some point, beyond a certain threshold, when you started scaling the server, unless you really knew what you were doing, you had a whole bunch of wasted server capacity, and the experience started to go down as with the number of concurrent connections. And now this is not only a problem of the database server, it's also a problem with the network. So a database server is connected to the outside world via some kind of network connection. So as the number of concurrent users go up, you experience a bottleneck. So again, this was another reason for the negative user experience. And of course, there's unused capacity. Now, NoSQL, what they did was, instead of scaling up a database, they scaled it out. So you spin up multiple instances and store your data on different instances. This increases complexity because you have to figure out which instance what data is stored in. But that's a different story. And they have built different managers to handle that. But that's still a level of complexity that you have to be aware of if you're hosting your own instance. One of the advantages of a NoSQL database that they discovered, and I don't know if this was accidental or by design, but they found out that as we scaled by adding more instances, if one of the instances went down, unlike a single server instance database, a NoSQL database would still respond. Now, it might give some kind of error message, but it's not a server not found error. It may give a different type of error. So this is a problem with most distributed systems anyway. So distributed systems are governed by something called a CAP theorem. It's also called Brewer's theorem, and this was introduced back in 2000 or so. What it means is that, let's say you're storing database on different servers. You have to account for these three factors: consistency, availability, and partition tolerance. Consistency means that when you write data to a database and you do a read immediately, you should get the same data that you wrote in. So let's say you insert a record into a table with value X, and you read the most recent record out of that table, you should get X, which means the system is consistent. And consistency is one of the basic tenets of relational databases, and we'll get to that in a minute. Availability is the fact that if a node fails, let's say you store your database on multiple nodes, right, multiple computers. If one of them fails and you query the system, you will get a response, but that response may lag in data. That's availability. And partition tolerance is the fact that when you have a widely distributed network, some kind of network outage could happen between the nodes, and you have to account for that when you design the system. So that is partition tolerance. So put together simply, they call the CAP theorem. So nothing smart over there. It's just an acronym. So going back to this one of the fallacy of distributed computing is that networks are reliable, right? So you try to assume that networks are reliable before you build anything, but that's not the fact. Networks and parts of networks go down frequently, and there are outages that may be beyond your control. Your ISP could be out, or there could be a power outage at some place. So network failures happen. So the reality of the CAP theorem is that you always have to account for partition tolerance. What does that mean? You have to always, the CAP theorem states that when you have consistency, availability, and partition, you can pick only two of those three factors. So you can either make it consistent and available, you can make it consistent and partition tolerant, or you can make it available and partition tolerant. So it's like the holy triangle, but you can only two sides talk to each other, right? You cannot have a circle that encompasses all three. The reality is that you always have to make a network partition tolerant. So that leaves you with two options. You can either make it consistent and partition tolerant, or you can make it available and partition tolerant. What does this mean? You always have to assume that there will be some kind of outage between two nodes of your network. So then you're left with a decision on what do you do with your data. Let's say I'm writing variable, I have variable X stored on both node 1 and node 2. And I replace the variable X on node 1 with Y. And my network goes down. If my database is consistent and I query node 2, it should node 2 is supposed to return Y. So it'll throw an error saying it was not able to get the latest. So you're deliberately throwing an error over there. Now, if I make my if I go with the second option and make my network available, and when this node goes down, or when this connection goes down, and I query node 2, I get the value X. And this is fine in a lot of instances. And this is one of the huge jumps that, one of the huge problems people have when they make a jump from the SQL world to the NoSQL world. Like, okay, so I just wrote in a value and I queried it, and I'm not getting that value back. What is this black magic, right? So, this is one of the basic tenets. That means your system is available. It was responding. Your system designer chose to make your system available. They did not choose consistency. So it's kind of like our version of the Mexican standoff, or what do we call it? So in the NoSQL world, ACID is the one of the basic tenets of the SQL world, right? Atomicity, I forget all the acronyms, but atomicity, consistent, obviously, isolated and durable, which is relational databases, right? NoSQL, ACID becomes base. So basically available means that it guarantees availability. You will get a response even if there is some kind of issues. The soft state means that your data is in a changes over time. So unless there is no more data coming in, you cannot be sure that you are reading the latest copy of data. So you have to, that's another mindset adjustment that you have to make with NoSQL. And eventual consistency, which is the E. It means that when you stop writing data to the system, after a while, all the nodes become consistent and they return the same data. Another principle, or I guess concept of NoSQL is called the 3 V's, which is volume, variety, and velocity. So this is interesting because people are often conflicted on, what should I use a NoSQL data store for? And they tend to think, oh, I'm getting large volumes of data. I may not get large volumes of data, so maybe I should not use it. Or I don't have wide data coming in super fast, so I should not use it. But there's another factor to that, variety. I actually started using NoSQL databases because of variety. When I started working in the IoT area, I got killed initially with because I did not know how to handle all the messages coming in. We kept adding different types of devices, and I had no clue how to handle these. But then I switched to a document-oriented NoSQL database, which is how I got started on this whole journey, and it helped me a lot. So there's 3 factors to consider. You can, if it satisfies any of these, you can probably try to start considering NoSQL databases. Having said that, I will say that you should not switch to a NoSQL database just for the sake of it, right? As a novelty. It's a huge leap to make, but these are some of the decision points that I'll be mentioning as I go along. Just to give you an idea of volume, Facebook in 2015 had 250 billion images. That is in 2015. I think it doubled or tripled each year since then. And To-Do List, which is an popular app, had 10 million installs. So obviously a lot of volume there. Velocity, again, Facebook in 2015 was doing 900 million photos per day. So that's a lot of data coming in at a rather quick pace. And variety, again, if you take a large CRM, for instance, it has data in spreadsheets, documents, PDFs, audio, video, emails. So there's a huge variety of data. And again, that's not the only type of variety. If you have device data coming in and it's a whole bunch of different schemas, that counts for variety too. So what are some different types of databases? And I'll quickly walk through these. You have 4 different types of databases. Document database, which is basically JSON documents. For that, you have MongoDB and CosmosDB from SQL API, and I think RavenDB is a document DB. There's a whole bunch of those. That's probably the most popular type of NoSQL database. But you also have Graph. Graph database is actually my favorite type of NoSQL database, and I'll show you why in a minute. Key value store, again, I use this quite frequently. Redis is a key value database. You simply store in values and retrieve them using a key, hashing principles. And column store, Cassandra and HBase, if you ever heard of these are column stores. I don't use them, but there's really good use cases for them. So a document DB or a document database, basically it has some kind of a key, and then it has data stored as JSON documents. So for instance, this boarding pass kind of translates to this in a document or in a database. So think of it like a denormalized database. So if you take a SQL user and you take their name and their skill sets and denormalize that into JSON document. That's what a document database looks like. And this, by the way, is and if you do front end work, document databases are really awesome to get data from, because most of them have really good APIs that you can connect to, and you can point your front end to those, and it really helps with front end development. The next one, this is my favorite one, is graph. So one of the problems that I've seen often with relational databases, and it's just each type of database has limitations, and one of the limitations of relational database is deep relationships, or the ability to add and remove relationships on a quick basis. So for instance, this is a graph database. So the circles are called vertices, and the lines are called edges, and each one has properties. So a vertex can have a property, a bunch of properties, and edges can have different type of properties. And as you can see that these properties are pretty flexible in schema. Again, one of the features of NoSQL databases is flexible schema. It comes across as you go across different NoSQL databases. By the way, how am I doing on time? Okay, all right. So this is a pretty good example. So James, age 32, apparently he has a Twitter account called Spam, lives with Mary of age 35. And James owns a car and Mary drives his car. Apparently they both love each other. And I guess because James lives with Mary, we have to assume that it's a house. So, it's a very symbiotic relationship. So, let's say Mary decides to stop loving James. It makes for a complicated relationship, but you can define one really easy with a graph database. So just saying that, when you see graph databases, there's one that I think it was last year at Microsoft Build, the CosmosDB team did a graph database that represented the entire Marvel comic universe, which was pretty awesome. Like you could literally click on one node and see how one superhero was related to another, and it would make a deep relationship. Although half of them are probably dead by now. Spoiler alert. Key value. So this is a really good or easy to use database. You put in a key value pair, dictionary key value pair, and you can retrieve using the key. And you can put in different types of data, depending on what type that particular database supports. But Redis is a very popular key value pair. I think everyone should try Redis as a cache for their web application. So you can start using that right away. There's nothing stopping you. This is a little bit more complicated, but I feel like I should talk about this. Wide column databases. So if you ever heard of Cassandra or HBase, those are wide column databases. And you'll see that they often have similar type of data, but each record may not exactly have the same columns. So what they do is they group by columns. So for instance, this one is grouped by the name column. And the theory behind this is that these are optimized to store queries over large data sets. And the theory is that certain columns or group of columns are more likely to be requested than an entire record. So let's say you have a record with 50 different columns. You can take 5 of those that are most frequently requested in reports and data analysis, and you put them in a Cassandra data store, and that really optimizes performance because it stores like all the column data in one machine or one cluster of machines, which really improves the performance. So these are really good for OLAP or OLAP, like workloads. Keep in mind that the data that goes into Cassandra database is often pre-processed. So you don't just take data out of your application and put it into Cassandra. There's a fair amount of knowledge and pre-processing that goes in. Okay, so decision time, should I switch from SQL to NoSQL? No, here. So I know I'm not here saying that you should use NoSQL. No, that's not the purpose of this talk. But you should consider polyglot persistence, which means that you probably should have at least, you should identify the data type. If it's caching data, you should probably put that in a Redis key value store, and so you can retrieve it with real quick performance. If it's deep relationships, you should probably put that in a graph database where after pre-processing it through SQL. So don't abandon your SQL database after leaving this talk. Please, that's not what I'm trying to give out here. So should you use NoSQL database as a service, which is, by the way, my next section. And to that, I say bleeping yes. Again, these are some of the differences between SQL and NoSQL that I could come up with. Feel free to take a photo of this, I guess. But some of the factors you want to look at is, does it meet the 3 V's, which is volume, velocity, and variety? Are you okay with being flexible on consistency? So that's one of the questions you have to ask yourself. Do you want to host it, or are you okay with it being as a managed service? And NoSQL, I generally recommend a managed service. Those are pretty complicated when you get into distributed computing. And polyglot persistence. So you have got to design your system to go across different data stores and get the data. So these are some of the factors that you should consider. For NoSQL database as a service, I'll quickly touch on the concepts and then we'll end this talk, but I wanted to quickly talk about this. Some factors to consider: total cost of ownership, consistency, throughput, latency, availability, partitioning, and global distribution. And I'll go through each one of these real quick. So the total cost of ownership, I have NoSQL on-premise in the blue, NoSQL on virtual machines in the orange, and Amazon DynamoDB and Azure Document DB, right? Those are the gray and yellow. So these are some of the numbers that people ran in testing. And what they found was, obviously, when you consider things like, you have to get a virtual machine to host your data, you have to hire someone to actually look after the virtual machine patches and optimize these database for performance and everything else. The overall cost of usage was much less for databases that you did not have to own infrastructure to host on. If you're okay with hosting them as a service, you obviously save money. But the thing is, right out of the bat, if you spin up the most basic level of, let's say, Azure CosmosDB instance, it costs $25, which it can kind of be a sticker shock for people who are used to doing MySQL databases for a few bucks, right? For single-digit bucks. So, but when you start scaling up, it saves money. So that's how I think about it. Consistency. So you have to choose either strong consistency or eventual consistency. It's the red pill, blue pill, I guess, conundrum. But what I would recommend is look for NoSQL databases that offer more than these two levels. They don't make you pick the two extremes. They offer something in between. So this should be an important decision factor if you're switching to a particular NoSQL database as a service. Now, keep in mind that it's creative. So they will creatively make it a middle ground. For instance, there's something called a session consistency, which means that if I have something, if I open a connection to a NoSQL database and I write it, I am able to read the data immediately. but others in the system may not, other readers may not be able to read it immediately. So that's kind of a middle ground, right? So they do that creatively. Latency, that's the, once you start writing and finish writing, or once you start reading and finish reading, the amount of time in between is the latency. Ideally, you want to have low double-digit latency in milliseconds. If it's single digits, that's even better. And again, when someone defines latency, ask them if they're talking about 50 percentile of their requests, 90, 99. I mean, what are they talking about, right? Oh, I have 1 millisecond latency. It could be for 50% of the requests. And so that really doesn't matter at all. So the other thing you want to see is one of the concepts of NoSQL is you add more servers, right? You want to, as you add more instances, you want to ask them, how long does it take for these instances to become fully performing? Throughput. So this is the whole thing of bandwidth versus throughput, right? Bandwidth is the capacity, throughput is the actual usage. So it's the amount of items passing in and out. So again, you wanna ask when someone is hosting NoSQL database as a service, what kind of throughput do you offer, right? It's when you get cable at home, you ask them what kind of bandwidth or throughput you offer. So ask the same thing of your NoSQL database as a service provider. And it should be some kind of standard unit. So make sure it's not a made up random thing in the marketer's head. Availability, this is important. People will say, oh, I offer 5 nines of availability. 5 nines of availability is really tricky. Let's say you're hosting a database instance on the Eastern, on US East, on any of your major providers, right? It goes down, what happens, right? So 5 nines is not possible unless you replicate it across instances. And then how well do these replicated instances perform? So again, availability 5 nines, be really careful when someone tries to sell you that. Partitioning, this is one of the, when you start with NoSQL databases, particularly document-oriented databases, partitioning is one of the most important factors, one of the most important decisions that you'll be making in your system design that could make or break it. For partitioning, what I generally suggest is that you pick the entity that has the most even distribution of database at any point in time. So in this case, this collects data from airports. So I use the airport ID as a partitioning key, because even if the airport in Australia sends more data at 9 p.m. And the airport in LAX sends more data at 6 a.m., over time they balance out. So I want to have a balancing act when I do the partitioning. Global distribution, your database provider, whoever it is, should make it easy to replicate globally. Like click of a button and how do I want my reads and writes to line out? So that is another important factor. And that's all I got. That's probably best to get in touch with me on Twitter. I'll be on here expressing strong opinions on things, so feel free to ping me on there. And thank you very much.
Let's see, check. Oh, okay. So we're going to do something different. If you guys have any questions, are you up for a question?
I'm happy to take questions.
Any questions? This is the speaking cube we're going to try out. So.
All right. Yeah, sure. Yeah, I love questions, man. Go ahead.
All right. I was a little bit curious about when you're talking about the 3 Vs. I'm trying to wrap my head around what the variety had to kind of do with it. I don't think I have a good, clear picture of that.
Okay, so the 3 Vs are volume, velocity and variety, right? So you said you're having trouble with the variety. Okay, so you can define variety in a couple of at least a couple of different ways. It's the type of data that comes in. It could be a huge variety. Like you could have data coming in that's metadata for documents versus images and everything else, right? And or you could have data that comes in that is the same type of entity, like it's a IoT device, but it's from different manufacturers. So each manufacturer created their own schema. And this is the problem that I faced when I had to design a system was, you go out and have something that collects data from all your devices, and one is made by Samsung and one is made by Apple and one is made by whoever, and each one sends, or let's say these are different types of sensors. I'm just giving an example, not that those are the manufacturers, but each one sends a different, they all tend to send similar types of data like temperature and whatever it is that they sense, but each one sends it in a different format. Some will have temperature as TEMP, some will have temperature, some will have TMP, and then they have a whole bunch of other columns that may or may not matter to you at all. So it's the schema is fluctuating wildly. So that is one of the most common types of one of the most common factors you have to consider when you look for a NoSQL database. Good question, though.
Thank you.
Have you used any NoSQL databases on the mobile devices? And what about replication down to those mobile devices?
So that's an excellent question. So I personally have not used NoSQL databases on mobile devices because I'm a cloud guy. But it's so when you do databases on NoSQL databases on mobile, I think Couchbase or
Couch and Pouch.
Yeah.
Right.
So you want to do for? Yeah, sure.
Don't. Yeah, I kind of looked at it. I didn't like it, but there's a couple of them out there that don't require an engine, right? It's just a DLL library to access the NoSQL
right.
database.
So the main thing you want to do is you want to make sure that the syncing process, there's a good, decent syncing process. And if you're getting the same data, if there's conflicting data, how does your main database instance handle conflicts? So that's one of the factors that you have to account for. But I think that Couchbase is a document-oriented database, if I'm not mistaken. So yeah, those would probably be the most likely ones to go on mobile, and handling conflicts is probably the most common problem that people would face with that type of databases. So,
Thanks. Once, twice.
one more question, going. No. All right. No,
right.
Singularity is not happening. No.
When you had your graph up before the cost of, like an on-premise database versus a virtual machine cloud-based, you had, I was trying to compare you had a VM, I think it was Aurora, and that had maybe half the cost of on-premise, but then there was the two cloud-based, which was AWS and then, so
Sure.
I was trying to figure out why was the VM so high, because I thought that would be virtual as well as the cloud.
So the numbers are back from 2015. So it's possible that its VM cost has dropped significantly since then. In fact, every time I go in and look at a VM cost, it seems to drop. So it's possible that it's different. But another thing to account for is I don't know how the study was conducted. It's possible they already had the infrastructure for on-premise, so maybe that the startup costs were less. So but the point I was trying to get across with that one was it's significantly more if you consider everything else like electricity and bare metal costs and everything for on-premise versus VMs, whatever the cost over there. It's significant. Those two are significantly more than if you hosted it as a service, even though the startup cost for as a service seems slightly steeper than some of the other SQL-based databases. Make sense? All right. Anything else? Any questions? Yeah.
So I guess the question I have then, joining into the conversation you just had about on-premises versus hosted, do you have any security concerns that you have to really take a look at when you start looking at hosted versus virtual machines or on-premises?
Excellent question. So when you're hosting, yes. So you want to obviously look at, go with providers who have certain types of certifications, like ISO type certifications, and you don't want to go with Joe's cousin who has a, who's running an instance and says it's in the cloud. That's not. So again, you want to look at someone who's been doing this for a while and they know how to do patches and not to take everything offline while doing patches. So usually I tend to go with AWS or Azure. So those would be the most common ones, but you'll find that when you go into AWS and Azure, they may have marketplaces or extensions that you can buy from third parties, and they usually vet those third parties they're pretty well vetted. So you can use those third parties if they're recommended by either Microsoft or Amazon or someone else. So that's how I tend to do it. I mean, I wouldn't go with Joe's cousin, definitely. So.
Thank you.
Sure. Oh. I hope you don't play baseball.
Do you know if services like Facebook or Instagram are SQL or NoSQL based?
They're polyglot. They probably use every kind of, they probably have some kind of SQL database, and but a lot of their data stores are NoSQL. And Facebook, for instance, definitely uses Graph, and I think they use some kind of Cassandra-based implementation. I don't know the exact internals, but I can tell you the story of Azure CosmosDB. It came up as a solution for some of the issues that I talked about earlier in the slides. It was an internal tool at Microsoft, and they developed it. And so when they started building this, what they figured was we're going to store document-oriented databases over here. But then they discovered that they needed to store graph-based databases. So soon what was DocumentDB became CosmosDB, and it can host different types of databases like graph and documents. So I would say each company, any company that does anything with Jack and technology, they probably use a variety of databases. Which is why I stress on polyglot persistence. You have to use the right type of data store based on your use case, and not a religion saying that, oh, I like document-oriented database. I'm going to try to fit everything into a document-oriented database. Try to use a wide variety, or look for the use case and use the right type.